All right, so the first step here is reading through the problem and determining what's really going on. So suppose in the icy hot lab that the burner transfers 325 kilojoules of energy to 450 grams of liquid water at 20 degrees Celsius. So the first step is to draw your graph. So you have time on the bottom. And then you have temperature here. And then you find out, okay, so to get to boiling, because it says we boil, we have to raise our temperature because we started at 20 degrees Celsius. And we know that water has a boiling point of 100. Okay, so you have to get up to 100. And then what happens? We start to have our phase change, which is a constant temperature. Okay. So looking at this, we have two segments. We have Q1, and then we have Q2. And what we're really trying to find here is what mass of the water would be boiled away. And so we're saying mass of the water that would be boiled away. So the mass of the water during that phase change during Q2. But first we have to figure out what Q1 is. So that's going to be our first step. Okay, so Q1, and then we have to figure out which equation to use. So Q1, we can see there is a change in temperature. So then we automatically, if there's a change in temperature, we go to our MC delta T equation. Okay. And then we can just plug things in. So we know our mass is 450 grams. Okay. Our C is given to us at the top of the worksheet, and for water, it's 4.18 joules times grams degrees Celsius. And then when you guys are taking the test, you have to write out these units, guys, because you're not going to understand what's going on if you just see a bunch of numbers, and it's going to be harder for us to grade if we just see a bunch of numbers. So C, this is our C. This is our M. And then our last variable is the change in temperature. So we always start with the final temperature. Okay, so we see Q1 is right here. We end at 100 degrees Celsius. So that's our final. Whoops. $100 degrees. And then we subtract our initial, which is 20 degrees. That's where we started at. All right. The next step would be to multiply all this together. Right here, there's a change in temperature of 80 degrees Celsius. Okay, so when we plug that all into a calculator, we get an answer of 150 kilojoules. Or 100 and so your answer could be 150 kilojoules or 150,000 joules. Kilojoules obviously is just a unit of joules divided by 1,000. All right. So step 2, we know that it takes 325 kilojoules of energy, all right, it transfers this much energy to that 450 grams of water at 25 degrees Celsius to boil it. So we know that Q2 can be found using the total Q. So they already give you the total Q. So total Q would be Q1 plus Q2. All right. So we can find Q2 by simply subtracting our values. So we can just do Q2 equals Q total minus Q1. All right. So we get our total of 325 kilojoules minus 150 kilojoules will give you an answer of 175 kilojoules. Now, this is our Q2 value. All right, and then this was our Q1. So the question is asking, what is the mass of the water that would be boiled away? So the last step would be to find M during this phase change. And I don't know why that. So M during this phase change. So we can use the Q2 and is equal to, and it's a phase change, so we know that we have to use heat of vaporization or heat of fusion in our equation. So in this case, we have liquid to a gas, so we'd have to use heat of vaporization. But we're trying to solve for M, so we have to do it a little bit differently, and we have to isolate that variable. Again, you guys have to show this on your tests. So we get mass is equal to Q2 all over heat of vaporization. Which is equal to 175. And in this case, I'm going to use joules, just because they give you the heat of vaporization at the very top of the sheet. They give it to you in joules, so you can do kilojoules and convert the heat of vaporization if you want, but I think it's just easier to do joules. Again, kilojoules to joules if you're going from kilojoules to joules, you have to multiply by 1,000. And then oppositely, if you're going from joules to kilojoules, you have to divide by 1,000. And then the heat of vaporization is at the top of your sheet. It's 2,260 joules per gram. Okay? When you work all that out, you get 77.4 grams